Okay, so continuing with parent functions now. We've looked at quadratic. We've pretty much been studying and looking at all the characteristics for a quadratic function. And again, these are just the parent functions. And by now, what you're going to use, and the way you're going to use this little chart here that shows you all the different families of functions, right? This is just the basic parent function, where the focus is on the vertex, right? Most of these, the vertex is at 0, 0. Focus on the vertex. Let me zoom in a little bit. The vertex and the shape, right? So we know that anything x squared is going to give us a parabola. And we've also looked at absolute value now as well. And it doesn't have a x squared, it has an absolute value of x, right? The two bars like that. And again, the critical point of the vertex is at 0, 0. Okay, but pretty much the same way and the same characteristics for this one as far as what makes it move left and right, and what makes it move up and down, and what makes it flip over, open downward. The same way and the same way that the properties apply for the quadratic, it's going to apply for the absolute value. Well, once you kind of get that understanding already, right? I know what the quadratic looks like. I know what the shape is. I know what the function is. You identify the function, and then you correlate it with its shape, right? With its corresponding shape. Well, now we're going to look at a few others, and we're just going to study all of them at the same time pretty much, because now that we know how to move and what makes this move left and right and what makes it move up and down, we just got to focus on the function and what the graph looks like. So we're going to be looking at square root now. The square root function. Again, yes, the parent function starts at 0, 0, and you got to know what the graph looks like. Just looks like that. That's it. We're going to look at a cubic function. Cubic function is to the power of 3. Again, the vertex, or that little critical point in the middle, is at 0, 0. But what does that look like? A cubic function is x to the power of 3 cubic, and it looks like kind of like half of a parabola this way, right? Kind of like half of it going like this, and this other half doesn't go up, it goes and it turns down. So that's the cubic function looking like this. And then also the cubed, this is the cube, this is x cubed or cubic. This is the cubed root. This one you see cubed, right, to the power of 3 is cubed. And this is the cubed root, right, because it has a radical. A cubed root. And if you're familiar with the way the cubed one looks, well, then the cubed root is going to be what? Well, it's going to look like this one, but it's now kind of going this way. Kind of half of a parabola, it's like sideways, right? So you see a cubed root, and then you're going to see a what? I believe also an exponential, which is down here, e to the power of x. Okay? So regardless of which one you see, mainly these three new ones here, just be familiar with the function, what the parent function is, and then what the graph is. Same thing here, exponential. Just looks like this. And this critical point is not 0, 0, it's actually at 0, 1. That point right there. Okay. So what is going to be true? Well, Just watch here. Again, if I have something like f of x is equal to x plus 5 squared minus 3. I already know by looking at this that the vertex is where? Remember, you got to do the opposite. Oh, by the way, if it's squared, I know it's a parabola. I know it's that U-shaped. I know the function is a parabola. If it's anything squared, it's a parabola. And the vertex is going to be what? You look here and you don't go to positive 5. It's the opposite. So that's negative 5. And this one is negative 3, right? You only do the opposite of this one. Or if you like to start, you can start in this. You can start at 0, 0. And then you don't go to plus 5. You go to minus 5. And then you go down 3, and that you'll see that the vertex matches. That's where the vertex is. I know this is opening up. Okay, so if it's a parabola, well, you draw a parabola. But what's the difference? What if it was absolute value? What if it was f of x is equal to x plus 5, or absolute value of x plus 5? And then minus 3. You see, I'm using the same thing. X plus 5 and x plus 5 is on the inside. That one has a square, so that tells me it's a parabola. This is absolute value. That tells me that that shape is that V-looking shape. But see, that inside number is the same, and this outside number is the same. So the vertex, just like over here, is going to be the same. It's going to be the same place. It's still going to be what? Opposite of this, negative 5, and then down 3. See, the vertex is going to be the same. It'll still be here, right? It's still at negative 5, negative 3. But obviously now here, because it was squared, you drew a parabola. Here, because it's the absolute value, you would draw a what? Well, you draw a V like this instead, right? So let's look at these new ones. Let's look at the cubic function down here. What if I have, well, again, f of x is equal to, what if I have x plus 5 minus 3? Well, just like the same numbers I'm using here, just like the same idea. If it's on the inside, right, just like it's in the inside of the parentheses, it's inside of the absolute value, it's inside here. What's the vertex? Remember, you do the opposite of this. So the vertex, again, is negative 5, negative 3. You see, the properties are the same. Negative 5, negative 3. The vertex is going to be here. Is it going to be a parabola? No. Is it going to be an absolute value? No. What does the square root function look like? Well, look at your graphs here. Look at your chart here. It just looks like kind of like an eyebrow like this, kind of just turning out. So just make it look like that. And if you're not sure, well, you can always use decimals to help you see the graph. Okay, so same thing with the cubic. If it was a cubic function, if it was the same thing, and if it was cubic, then it was like this. F of x is equal to x plus 5, and now it's cubed minus 3. See, it's the same thing. Your vertex is still at negative 5, negative 3. And just know that a cubic function is what? A cubic function looks like, well, look at your chart here, is this. So it'll still be, the vertex will still be here, but now you just draw the correct graph, right? For this function, cubic function looks like kind of half of a parabola this way and the other half going this way. Okay. The last thing I wanted to talk about, or actually, yeah, the last thing here I wanted to talk about is, this is the positive absolute value of x. What is it when it has a negative, right? What is it when it has a negative? Well, I know these up and down. I know these open down, and let me get my other paper. Okay, so actually on the back side, right? On the back side, flip it over, and we have again the same thing, but I did this on purpose, right? So actually on the back side, put a negative here and draw the way it looks when it has a negative in front of it, right? That's this one, not this one, right? Same thing with the parabola, right? I should have done that one first. This is, if it has a negative x squared, it's going to look like this. It's going to open down, right? The vertex is there, vertex is there. What does it look for the other ones? Well, if you notice the negative does what? It rotates. It's a reflection of the graph along the x-axis. It's like you fold it over on the x-axis. That's what that negative does. So if I have this graph and I have to fold it over on the x-axis, the negative square root would look like this. Just this graph, right? And the cubic, if you have the negative, would look like this. So I just want to make sure I cover that, and you're aware of what the negative, what it looks like when it's negative. When it's positive, it's like this. When it's negative, well, it's going to be like this. This is the negative x cubed, right? That's what we're focusing on. Make sure you put that negative there. This is for the negative one. And lastly, for the exponential, should look like this with the negative. Okay. All right. That's it. Good luck with these, and use the chart to help you know how to graph the function.